Hey folks, today we're talking about something that might not seem glamorous at first, but it's a total workhorse in the world of data, CSV files. Whether you're working with spreadsheets, APIs, databases, or just trying to clean up that messy export that your colleague gave you, CSVs are everywhere. And good news, Python makes working with them surprisingly painless. In this video, we're going to cover how to read, write, and transform CSV files using Python's built-in CSV module. CSV stands for comma-separated values. Think of it like a text-based spreadsheet. Each row is a line in the file. Each column is separated by a comma. Here we've got an example where we've got name, score, and email in the first row, separated by commas which represent the column names. Then in the second row, we've got values which correspond to the column names which are also separated by commas. It's just plain text. No formulas, no styling, but easy to read, easy to write, and supported by everything from Excel to Google Sheets to data processing pipelines. This is your basic CSV reader. We open the file using open, pass it to CSV reader on the next line, and then loop through each row. Each row is just a list of strings, one string per column. If your CSV file looks like this, then the first iteration gives you name, score, the second, Alice, 95, and so on. Something to keep in mind is that when reading CSV data in from a file, every value will be read in as a string. So in cases like this where score should be an integer, it's up to you to cast it to the correct data type. Most CSVs start with a header, the column names. If you don't need it or want to process it separately, just skip it like this. The next call reads the first row and moves the iterator forward. After that, your loop processes just the data rows. If you need to reference your header columns later on, just save it to a variable like we've done here. So we've taken a look at CSV Reader, which returns each row as a list. The drawback here is that we need to reference each item by its index in the list. But thankfully, we do have another option, and it's called Dict Reader. With Dict Reader, each row is a dictionary where keys come from the header row. This makes your code way more readable. Instead of remembering that index 1 of a row is the score, you can just use the score key of the row dictionary. And this is especially helpful when your CSV file has a lot of columns or if the column order might change. We're not relying on positions anymore and can instead refer to column names. As you can see in this code, we follow the same pattern as we did before. First, we open the file using open, then we pass it to csv.dictReader on the next line, and then we loop through each row. And that's it. CSV Reader and Dict Reader follow the same pattern, but with Dict Reader, your rows become a lot easier to work with. Now that we've got a handle on reading CSVs, it's time to dig into writing them. Fortunately, Python makes writing CSVs just as easy as reading them. Here we define our data as a list of lists. The first sublist is our header, and the rest are the data rows. Next, we open a file in write mode, which is what the W is for. Then we create a writer and pass the file to it. And lastly, we call write rows by passing our rows to it. If you need a bit more control over what happens with each row, you could loop through each row to write them individually by calling writer.writeRow on each row like we've done here. Just like we've got a reader and dict reader, Python also gives us a writer and dict writer. Dict writer is your go-to when your data is already in dictionaries, which is pretty common when working with APIs, JSON, or form data. Okay, so let's see how this works. First, we define a list of field names, which will be our column headers. Next, we define our data, which is a list of dictionaries. In this example, we're including every column header. But if you're only interested in specific columns, you're free to just leave them out of your field names. This is handy when you're getting your data from a third party like an API or database export. In those cases, you might need to create a CSV file which only includes a subset of the original columns. Now that we've got our field names and data set up, we open a file in write mode just like we did with the standard CSV writer. But here's where things are a little different. When we create our writer using csv.dictWriter, we need to not only pass in the file name, but also the field names. This tells the dictWriter what our column headers will be. Once we've got our writer, we write the header row using writer.writeHeader. And lastly, we write our row data. Keep in mind, you can also write each row individually if you need to, by looping through the data just like we did with the standard CSV writer. Let's move on to a slightly more complex real-world example. When you're working with CSV files, you'll often find yourself needing to open an existing CSV file, modify or parse the data in some way, and then write a new updated file with the changes you made. For this, a good rule of thumb is to leave the original file as is, while saving your updates to a new file. That way your source data remains intact. Okay, so for our example, we're going to have a new CSV file which looks like this. We've got our existing name and score columns, but now we've also got an email column. What we're looking to do is create a new CSV file based on this data, which has two changes. First, we don't want the email column included. And second, we need a new status column, which will have a value of active if score is over 80, otherwise the value should be inactive. All right, let's step through the code to see how we can get this done. First, we open our input and output files. Notice how we're able to do this with a single context manager. This ensures both files will be closed when we exit the with block. In our with block, we pass our source file to a dict reader, just like we've done before. Next, we need to define the field names that should appear in our final output file. To do this, we have a few options. One would be to hard-code the list. But what if the source file has a lot of columns? We probably don't want to waste time hard-coding 50 columns. So instead, we can use a list comprehension to get all the existing field names from our source file using reader.fieldnames. We can also exclude the email column while we create our list comprehension. And lastly, we add a new status field name. So now we've got the field names for our new CSV file, which includes all of the previous columns except for email, plus an extra status column. Next up, we create our new dict writer and pass in the output file and field names. After that, we write our header row just like we've done in the past. Now for the interesting part, we loop through all our rows one by one. And we keep in mind each row is a dictionary, which means we're able to delete the email key value pair on each iteration. We then set status in the row dictionary based on the value of score. And lastly, we write our row using writer.writeRow. And that's it. We've read in a CSV file, made some changes to the data, and written it to a new file. This is a pretty common task, and Python makes it dead simple. If this helped you out, give it a like, subscribe for more Python tips, and check the links below for the full blog post which covers CSV files in more detail.